In this video, we're going to solve two quadratic equations by completing the square. However, what's different from this video when compared to the last video is that the two equations we are going to solve do not have leading coefficients of 1, whereas the two equations we solved in the last video did have leading coefficients of 1. And this is a problem because I don't know how to solve this problem. But I do know how to solve it when the leading coefficient is 1. So I'm going to take a problem I don't know, and I'm going to reduce it to a problem I do know how to solve. So how do I reduce this leading coefficient to 1? Easy. Divide the left-hand side by 2. If I divide the left-hand side by 2, well, I have to divide the right-hand side by 2. I distribute the division, right? And I get 2u squared over 2 minus 12u over 2 plus 18 over 2 equals 0 divided by 2, which is, of course, 0. Doesn't matter what I divide 0 by, it's always going to be 0. And, of course, here's the beauty. I just reduce this problem to a problem I do know how to solve, because 2 divided by 2 is 1. My leading coefficient is going to be 1, and I do know how to solve this. I do, said the lion in The Wizard of Oz. So 12 is divided by 2 6 times. So that's going to be minus 6u. And 2 goes in 18 9 times, so that's going to be plus 9. That's going to equal 0. All right, here's my leading coefficient of 1. I know how to do this. First thing, just like last time, get rid of that constant on the left-hand side. And that leaves me with u squared minus 6u. That goes away, equals minus 9. And what do I add? Well, I know what I add. I take 6, this number here, divide it by 2, and I square it. And, of course, if I do it to one side, I have to do it to the other side. So I'm going to add 6 divided by 2 squared to the other side. This becomes u squared minus 6u. Oh, sorry, that should have been a minus. Turns out it's not going to matter. Whether it's minus or plus, it's going to go away. But when we reduce it to a perfect trinomial square, the minus sign is something to be cognizant of. Anyway, 6 divided by 2 is 3, or minus 3, and minus 3 squared is 9. So this is going to be 9. And do it to this side. That's going to be plus 9. Ooh, that's going to equal 0. Interesting. Interesting. Well, okay, so this is u. Remember, this is now minus, and it's going to be minus 3, right? Minus 6 over 2 is minus 3. And that's squared. That's going to equal buckus. Nada, thwack, tilde, tada. So I have this as a perfect trinomial square, which means I can now apply square root rule, take the square root of both sides, recognize that I should put plus or minus before the second square root sign. This is reduced very quickly to that. Plus or minus the square root of 0. Well, square root of 0 is 0, and there is no plus or minus, so it's just going to be 0. Oh, this is interesting. We're only going to have one solution, as opposed to our usual 2. So let's add 3 to both sides. And what do I get? I get u equals 3. All right, let's check our solution. Check u equals 3 in, what's our equation? 2u squared minus 12u plus 18 equals 0. 2u squared minus 12u plus 18 equals 0. All right, let's check that. 0. We only have one solution this time, and it's 3. That's okay. That's interesting. Okay, now let's solve the second problem. The second problem is the same idea. I don't know how to solve it in this form that it's in, so I have to change it to a form I do know how to solve. And that means I got to get rid of that 4, and I know how to get rid of the 4. I'm going to divide both sides by 4. Now, I got to point out here, I like to reduce the problem to something I know how to solve right away. The book it waits till the second step, till you move this over to the other side until it does the division. I don't know why it does that, but just a different style. So if you want to do it the way the book does it, be my guest. You want to do it this way, be my guest. I like doing it this way because I like to reduce a problem I don't know how to solve to a problem I do know how to solve right away. That's the kind of guy I am. So this is we're gonna distribute the division of 4 across the addition and subtraction. So that's going to be 4x squared over 4 plus 4x over 4 minus 15 over 4. And 0 divided by 4 is, of course, 0. The whole point was to get rid of this, to make it a 1, so it now gets reduced to a leading coefficient of 1, which I know how to solve. And this is going to get reduced to 1, so that's going to be x minus 15/4. Oh, fudge. I'm going to be stuck with a fraction. Well, I may not like fractions, but I can deal with it. So let me deal with it. All right, again, I get rid of that by adding 15/4. 15/4, not 15/5. 15/4. Sometimes my hand doesn't know what my mind is thinking. What am I doing? I'm adding 15/4 to both sides of my equation. That gives me x squared plus x plus something I'll add later is going to equal 15/4. So what do I add later? Well, I have a 1, but I have to divide that by 2, and then I square it. Okay, so I have another fraction. Got to do that to both sides, though. So that's 1 over 2 squared. Okay, so, ladies and gentlemen, so that's x squared plus x plus 1/4 equals 15/4 plus 1/4, which is 16/4. That's 1, that's going to be 4. Oh, we got rid of a fraction. Okay, so this guy is going to be x plus what's in here, which is a half, squared equals what? 4. All right, I mean, this is now the 4th time we've done this kind of thing. We now have a perfect trinomial square on the left, so we're going to apply square root rule. Square root of both sides, plus or minus on the right-hand side. That reduces to this. That fraction wasn't so painful. Plus or minus, square root of 4 is 2. So now it's going to get a tad ugly, because I'm going to subtract a half from both sides. So I get what? X equals minus 1/2 plus or minus 2. Now, what's that going to equal? That's going to equal minus 1/2 plus 2, or, and, minus 1/2 minus 2. All right, so that's 1. Let's do that. It's 2 over 2. That's a 1. That's 2 over 2. So this is going to be 4 over 2. 1 over 2 minus plus 4 over 2 is 3 over 2. And this is minus 1 over 2 minus 4 over 2, which is going to equal minus 5 over 2. All right, these are improper fractions, but I'm not going to make a big deal out of it. I'll leave them that way. We should check this, although it's going to be a little painful. All right, do we have enough room? Let's check. Let's check for x equals 3/2. All right, what's our formula? What is our formula? It's up here somewhere. 4x squared plus 4x minus 15. Does that equal 0? 4x squared. Oops. Short-term memory is getting shorter. What was it? Plus 4x minus 15. Plus 4x minus 15. Does that equal 0? So let's try it for this guy. So now I have 3 halves, 4 times 3 halves squared, plus 4 times 3 halves, minus 15. Does that whole mess add up to 0? Well, 0 equals 0. That solution works. Let's see if I can do it for the other solution. Let's see if I have enough room. If I add the negative numbers, I get 25 minus 25. That equals 0. 0 equals 0. So this, in fact, works. Okay, so what do? We completed the square with two equations that did not have a leading coefficient of 1. One had a leading coefficient of 2. The other had a leading coefficient of 1. Well, first thing we did is we made the leading coefficient 1 by dividing by the reciprocal of 2, which is 1/2. Or dividing by 2, sorry. Multiplying by 1/2, same thing. Likewise, we want to get rid of the 4, divide by 1/4. That reduced to the problem we already know how to solve. Presto changeo, no problemo. We solved this solution, we checked the solutions, and they worked. Next time, we're going to solve another quadratic equation, but this time, the solution is going to be a complex number. All right, see you next time. Bye now.